As you can probably tell, I don't have any ideas for new content. And it's hard to get ideas because there aren't many amateur-friendly complex AI concepts. And I know my last video was pretty difficult to wrap your head around, but I really am trying to make these videos as understandable as possible for all levels of programmer. So I decided to ask my friend ChatGPT for some help. What the hell? And then I realized, I'm always getting AI to do all the thinking for me, so why don't I just make my own AI and train it so it can replace my own brain? Wow! Wow, that was a pretty sick transition. I know, right? So how are we gonna do this? Honestly, it's pretty simple. In theory. But we'll get to that later. My goal for right now is to make a neural network that can solve one very simple problem. Which dots are on top of the line and which dots are below it. This is how neural networks are typically visualized. This one in particular has 3 hidden layers, 3 inputs, and 1 output. What does this mean? Well, put simply, we're telling it 3 things, possibly x, y, and z coordinates. These little lines are essentially just numbers between negative and positive 1, and all that they do is multiply the input value by their own value. Now let's forget about all this other junk for a sec. We've still got our input and our hidden layer, but I've removed all of the other unnecessary nodes for now. Now what this hidden layer node does is it basically just chooses when to activate itself. Let's just say for now that if the value is more than 1, it activates, and if the value is less than 1, it doesn't. Now let's add in our outputs. The node in our hidden layer sends a signal to the output. If the node is active, it sends a 1, and if it's not, it sends a negative 1. All the signals from all the nodes are then added up to create the output. Now let's look at a slightly bigger network with the same rules for activation. It's important to note that each input is sent to each hidden node. And it's also important to note that the weighted inputs are added together before being sent to each node. In order to get an output that is between negative and positive 1, we divide the added hidden layer outputs by the amount of hidden nodes. Then we can say that if it's less than 0, it's off, and if it's more than 0, it's on. Now, here's the question we're all wondering. How does it learn? All you do is tweak the weights until they're correct. This is done by showing it a desired output and forcing it to change its weights in the right direction. Okay, even I'm confused at the moment. So let's try and program it, and hopefully that'll help it make more sense. The code itself is pretty simple, but because I'm really messy, it took me a little over 100 lines. But someone smart could for sure do it in like 60. Alright, let's take a look at how the code actually works. This code is really poorly done, so don't look at anything I don't point at. Over here we have 3 things. The output, the list of points, and the amount of points. Why did I declare the output here? I don't know. Now we use those variables to make a new point and add it to the list of points. The amount of points that we make will be the same as the variable we set earlier. Now in here we just draw the line that separates the points, and down here we guess where the point is, and then train the networks again. Here is where we make the actual points. Each point has its own neural network. Why? Here we set the x and y coordinates of the point and assign it random weights. Then we set the inputs for the network as the x and y coordinates of the point, and depending on the network's guess, we assign the points certain colors. And here we label the point as being either above the line or below the line. This part is hard-coded. Okay, wait a minute. I don't want to overwhelm you with too much information, so it's time for a fun fact. Cube-shaped? The hell? This just makes it so that if the network guesses wrong, it gets retrained. Why didn't I do it all in that one if statement? Because I'm an idiot. Leave me alone. Like I said earlier, you times all the inputs by the weights and then add them together. You better have been listening. I can't really point it at you, but you get what I'm saying. Okay, here's the cool math stuff to tweak the weights. Pause if you want to look at that. This function just decides if the node will be on or off like we talked about earlier. And we just use it up here. Okay, that's a lot of explanation, but let's see if it works. I've got the learning rate set pretty low for this first one, and all that does is just control the amount that the weights get tweaked. And as you can see here, if you set the learning rate a little bit higher, it solves the problem much faster. The only problem is that with more complicated problems, you'll be able to see that a higher learning rate means less accuracy.